So in this problem, we are asked to solve a uh, second order differential equation with constant coefficients, non-homogeneous. Sorry, e minus t under the initial conditions y of 0 equals 0 and y prime of 0 equals 0. So first of all, variation of the parameters will help us solve this second order differential equation easy. That's not an issue. But the question is to use Laplace transform. So the problem here is not about solving the IVP, but to check on us whether we know how to use the Laplace transform. Number one. Number two, the initial conditions may sound bizarre to some extent, but this is just to find the particular solution. Y of 0 equals 0, y prime of 0 will give you one solution of this differential equation, non-homogeneous, and this way you have the yp, the particular solution. Okay? So anyway, so we want to use Laplace, so we go Laplace of y double prime plus 4 Laplace of y prime plus 5 Laplace of y equal Laplace of e minus t. So Laplace of y double prime, that is s squared Laplace of y minus s y of 0 minus y prime of 0 plus 4 times Laplace of y prime, which is s Laplace of y minus y of 0 plus 5 Laplace of y equal Laplace of e minus t, which is according to the table s plus 1. So now let's put the stuff together. We have this term with this term with this term. Together gets us s squared plus 4s plus 5 Laplace of y. And then we have y of 0, 0, y prime of 0, 0, and y of 0, 0 equal 1 over s plus 1. Therefore, Laplace of y is equal to 1 over s plus 1 times s squared plus 4s plus 5. So we found the Laplace transform of the unknown function, and now we need to find y by using the inverse Laplace. And so now what we know that y of t is going to be the inverse Laplace of 1 over s plus 1 times s squared 4s plus 5. Okay, so for that we need to do a partial decomposition technique. We know that s plus 1 s squared for s plus 5 is going to be equal to a over s plus 1 bs plus c over s squared plus 4s plus 5. I forgot to mention that s squared plus 4s plus 5 has imaginary number, so we cannot factor it anymore. So in this problem, I'm gonna fully complete the whole calculations, and I'm gonna try to find a, b, and c. So let us now reduce the same denominator. So we'll get a times s squared plus 4s plus 5 plus s plus 1 times bs plus c over s plus 1 times s squared plus 4s plus 5. And now, since we have the same denominator, we must have the same numerator, which gives me a times s squared plus 4s plus 5 plus s plus 1 times bs plus c equals to 1. So now let us rewrite the whole thing as one polynomial. So we get, in other words, first we develop the whole expression for as plus 5a plus bs squared cs bs plus c equal 1. And now regroup them. So we'll get a plus b squared plus 4a plus c plus b times s plus 5a plus c equals 1. So since we don't have a squared on the right hand side, we get that a plus b equals 0. No s for a plus c plus b equals 0. And finally, 5a plus c equals to 1. That's the constant term. Okay? So the first one gives me b equal minus a. And if I replace in the second equation, I will get for a minus a plus c equals 0, or 3a plus c equals 0. So I have these two equations only with a and c, which is 3a plus c equals 0, 5a plus c equals 1. If I take the second equation minus the first equation, I will get 2a equals 1, or a equals 1 half. So I found a, therefore b is equal to minus a minus 1 half, and from this equation I get c equals minus 3a equals minus 3 half. Okay, so this tells me that my decomposition now is 1 over s plus 1 times s squared plus 4s plus 5 equal, here 1 half for a, 1 over s plus 1, and then plus 1 half minus s minus 1 half for b, and minus 3 half for c over s squared plus 4s plus 5. So I can take the minus out. 1 over s plus 1 minus 1 half times s plus 3 over s squared plus 4s plus 5. Now, in order to find this one is easy, it's e minus t from the table. But for this one, I need to complete the square at the bottom to be able to use sine and cosine. So this will give me 1 half, 1 over s plus 1 minus 1 half s plus 3 over, once I complete the square, I get s plus 2 squared plus 1. So since I have s plus 2 squared plus 1, this reminds me of the sine and cosine of t, but with e minus t minus 2t in the front, because I have s plus 2. So this s plus 3 that I have here, I have to work with it to get s plus 2. So I can use the table. So I have s plus 2 plus 1 over, so s plus 2 plus 1, that's s plus 3, s plus 2 squared plus 1. And now I divide, so I will get 1 over s plus 1 minus 1 half s plus 2 over s plus 2 squared plus 1 minus 1 half 1 over s plus 2 squared plus 1. So here now, this is Laplace of 1 half e minus t. This one will give me plus Laplace minus 1 half, and here I have to use minus 2t cosine t plus Laplace minus 1 half e minus 2t sine of t. So now I found my y, so it's going to be the 1 half e minus t minus 1 half e minus 2t cosine t minus 1 half e minus 2t sine of t. Just a quick note here. How did I get the e minus 2t? So remember, so we have Laplace of cosine beta t, that's s over s squared plus beta squared. And the Laplace of sine beta t is 1 over s squared plus beta squared. So when I multiply by e alpha t, I shift cosine beta t. I will shift, so it's going to be s minus alpha over s minus alpha squared plus beta squared. So you see, that's how we get, and the Laplace of e alpha t sine beta t, we shift it again. Wherever you see s, you put s minus alpha. So you see here, if you take alpha equal minus 1/2, it becomes s plus 1/2. I'm sorry, alpha equal minus 2, you get s plus 2, s plus 2. And if you take beta equal 1, you get 1 squared, that's 1.